All right, so we're in section 7.6. We're talking about spheres today. So let's start out like we did with all of our other solids and figure out what is important, what makes a sphere, what's special about it. So three-dimensional. We know a sphere is a 3D shape. I'm just going to call it a figure. What else do we know about spheres? Has something to do with a circle, right? It's round. It only has one side. It doesn't really have a bunch of sides, yeah? No vertex. No base, really. So we're going to just call it, we'll kind of put all those things together and we'll say, we'll just call it a curved surface. So it's a 3D figure that's a curved surface. The way we define a sphere, and I don't think we'll talk about it in this class, but in pre-calc, if you go to pre-calc, we'll talk about the equation of a sphere. The way we define a sphere is that it's all points that are the same distance from the center. And we'll talk about circles this way a little later in this semester. And spheres are kind of like circles. Spheres are like three-dimensional circles. That's the way you could think about it. So our definition is all points that are the same distance from the center. And we call the distance is the radius. So there's really only one thing that we need to worry about with spheres, and that is the radius. That's the only thing we need for our formula. So let's get a picture up here of a sphere, and we'll label our parts. All right. There's our sphere. So we'll label this R. This is our radius. Yeah, if I were to sketch this, I would just draw a circle like so, and then like this, and there would be my sphere. A little lopsided. And this point here is the center. So this is all we need for our formulas is the radius. Now, in your homework, it's going to talk, it'll ask you questions about a hemisphere. A hemisphere just means half a sphere. So when the problem asks you about a hemisphere, it's just asking about half a sphere. And you know the engines, they talk about Dodge as having Hemi engines. The reason they call them a Hemi is the top of the piston is dome-shaped, like half a sphere. So that's why they call it a Hemi, because the top of the piston is like a hemisphere, and it gives it more compression. So that's where the Hemi comes from in those engines. All right, so let's get to our formula. The surface area, since we started with surface area with all of our other shapes, we'll start with the surface area of a sphere. So the surface area of a sphere, all we need is the radius. That's all we need to plug into our formula. Our surface area is 4 pi r squared. And our units are square units. Now, where our formulas come from, it's a little harder to describe with spheres. We can't just flatten it out and draw a net because a sphere is curved everywhere. For the surface area, one way that you can think about it is if you fill a sphere with a bunch of tiny pyramids, and the base of the pyramid would be the outside of the sphere, you can add up all those bases, areas of the bases, and come up with this formula. So that's one way you can do it. But in general, it's a little tricky to come up with our formulas. And our volume. We'll do our volume, and then we're going to do some examples. Volume of our sphere. Again, all we need is the radius. Our volume is 4/3 pi r cubed units cubed. That's our formula. 4/3 pi r cubed. Now, when we're calculating with this fraction, you can do it a couple of ways. You can multiply pi times the radius cubed, multiply that whole thing by 4, and then divide by 3. That'll give you your answer. Or you can just divide 4 by 3 in your calculator, turn that into a decimal, and multiply that decimal times pi r cubed. So either way works.
Like, can we divide the pi r cubed by 4 and multiply that by 4?
Yes, you could also divide pi r cubed by 3 and then multiply by 4. Since this is all multiplication and division, it doesn't matter which order you do it in. And we'll do a couple of examples in just a minute. So any questions about our formulas? Now, spheres are nice because we only need this one piece. With all of our other formulas, we needed at least one other piece. We needed a radius, we needed a height. We needed an area of a base, and we needed a height. We need a slant height for all of our other shapes. For a sphere, all we need is the radius. So usually the trick with problems involving spheres is figuring out the radius. All right, let's do a couple of examples. We have a hemispherical dome. The diameter is 142 feet. And we want the volume. So hemisphere, that just means half a sphere. So we have something that looks like this. We have a dome, and the diameter is 142 feet. So our formula, our volume, because we have a hemisphere where we just have half the sphere, our volume is going to be 1/2 of 4/3 pi r cubed. It's just going to be half the volume of the whole sphere. So if our diameter is 142 feet, our radius is what? 71. Half the diameter. So our radius is 71 feet. And I'm going to plug that into my formula and calculate. 1/2 of 4/3 pi times 71 cubed. When I cube 71, I'm just going to write this out. 1/2 of 4/3 pi times 357,911. That's 71 cubed. And when I multiply this all out, in my calculator, what I would do is multiply 357,911 times pi times 4, divide that by 3, and then divide that whole answer by 2. If I calculate that out, I get finally that my volume is 749,227.03 cubic feet. So this hemispherical dome would hold about almost 750,000 cubic feet of volume. Questions on the calculation, on how we use the formula?
Can you go back?
Go back one page, sure.
Yeah, so you didn't write 1/2.
This one is the volume of a sphere. Our problem said we had a hemispherical dome. So that's where that 1/2 came from. Okay? Hemisphere just means half. All right, let's look at another example. We have a baseball. With a diameter equals 2.9 inches. We want to know how much leather to cover it. So we're making a baseball. The diameter is 2.9 inches. We want to figure out how much leather would cover it. So if we're talking about covering it with leather, what quantity are we wanting to measure? Surface area. We need the surface area. So we want to find the surface area of this baseball to figure out how much leather we need to use. So our surface area.
Are these questions out of the book?
Yeah.
I thought you were just making them up.
So our surface area is 4 pi r squared. We have the diameter, so the radius is half of that, 2.9 divided by 2. So the radius is 1.45 inches. So I'm going to plug that into my formula. So the surface area is 4 pi times 1.45 squared. Or 4 pi, 1.45 squared gives me 2.1025. And when I calculate that out, that is about 26.42 square inches. So it would take about just over 26 square inches of leather to cover this baseball, to make the cover for that baseball. Yes? Okay. Questions on that calculation? All right, let's do one more example, and then we'll be done. As soon as my computer catches up here. All right, I don't know what's going on with this. Let me try this. All right, let me see if I can figure this out. All right, so let's look at another example. We have a sphere. And our volume equals 1,000 cubic meters. Yes.
Oh, me? No, oops.
And we want to know the radius. So this is like our problems with our cylinders, with our pyramids, where we have one part of our formula and we need to figure out the other. So we're going to plug in what we know and solve for what we don't know. So our volume, we know, is 4/3 pi r cubed. So we're going to plug 1,000 cubic meters in for the volume. And that equals 4/3 pi r cubed. And we need to find r. We need to get r by itself. So to get rid of this 4/3, I'm going to multiply by the reciprocal times 3/4. These cancel. 3/4 of 1,000, I can multiply 1,000 by 3 and divide by 4. That gives me 750 equals pi r cubed. I'm going to divide by pi. 750 divided by pi is about, I'm going to turn this around, r cubed equals 238.73. Now undo this cubed. What do I have to do to undo this cubed? Cubed root. So the cube root, if I plug this into my calculator, the cube root of 238.73, I get about 6.2 meters. So if my volume is 1,000 cubic meters, my radius is about 6.2 meters. And I found that by finding the cube root. Questions on that one? Okay, one other thing that comes up in your homework. If I have a circle, and I know the area of the circle, how do I find the radius? Let's say the area equals 200 square units. How do I find the radius of that circle? What's our formula for the area of a circle? Pi r squared. So area equals pi r squared. Let's plug this in for the area. 200 equals pi r squared. Divide by pi. And r squared equals 200 divided by pi, whatever that number comes out to be. And then to find my radius, I take the square root. So the radius equals the square root of 200 divided by pi, whatever that decimal comes out to be. So if you have the area of a circle, you can find the radius. That comes up several times in your homework assignment, where you have have an area and you need to find the radius of the circle. So you plug into your area formula for your circle and find your radius from that. Okay? All right. Let me pass out your folders.